Hi everyone, in this video we are going to solve three very interesting problems from height and distance. Here I have the first question which I took from 2023 JEE main exam in India. However, I took a little liberty to slightly modify the question, but the main idea came from that particular paper. Here the question says, from the top of a 50-meter high tower, the angle of depression of a point S on the ground due south is 45 degree and the angle of depression of another point W on the ground due west is 30 degree. What is the distance between the 2 points S and W? So we have been told that there is a 50-meter high tower and there is a point S on the south side of the tower and the angle of depression from the top of the tower to that point is 45 degree, and similarly there is another point on the west side of the tower which is the point W and the angle of depression of W from the top of the tower is 30 degree. We have to find the distance between S and W. So let's get started with the solution. First let's draw a little diagram. I'm going to draw the tower first. Let's suppose this is our tower, the vertical yellow line PQ standing upright on the ground, and the height of this tower is 50 meters, so I have noted that. And now let's select the 2 points on the ground, point S which is apparently on the south side of the tower and point W which is on the west side of the tower. Since Q, S and W they all lie on the same plane which is the horizontal plane at the ground level, let's connect W with Q and also let's connect S with Q. Now I am going to connect W with the top of the tower which is P, that is our line of sight, and that's going to look like this. Now I have noted the angle of elevation here, but the question says angle of depression. Because it is a 3D kind of diagram, I thought showing the angle of elevation would be easier, so I am showing it in terms of angle of elevation. But we know that the angle of elevation of the tower from this point will be equal to the angle of depression of the point from the top of the tower that we have learnt in the first video. So even though the question says angle of depression, that will be equal to the angle of elevation as long as we are talking about the same top of the tower and the same point on the ground. Now I am going to join the line of sight from S to P, and there I have noted that the angle of elevation is 45 degree because the question says that the angle of depression of point S from P is 45 degree, and we know that it will be same as the angle of elevation of P from S, so I have noted it as the angle of elevation. And then finally I have connected W and S. This is the straight line distance that we have to calculate. In this diagram there are actually three right triangles. So let's review them one by one. First let's talk about the triangle PQW. Triangle PQW will be a right triangle because if you think about it, the angle PQW is actually 90 degree because PQ is standing upright and QW is at the ground level, so the angle between the tower and the ground level, that will be 90 degree. So then triangle PQW is a right triangle. Similarly, if we look at the triangle PQS, that will also be a right triangle because QS is at the ground level, PQ is standing upright on the ground, so that angle PQS will be a 90 degree angle, it will be a right angle. So the triangle PQS is a right triangle. Next, if we think about the triangle SQW, that is also a right triangle. Why? Because the angle SQW, that angle will be a right angle because we are talking about the south direction and the west direction. We know that south and west they form a 90 degree angle. So angle SQW will be a right angle. That means the triangle SQW will be a right triangle. Now for the right triangle PQW, let's take a tangent ratio of the 30 degree angle there. Can we write it like this? Tangent of 30 degree will be equal to PQ over QW, opposite over adjacent, and from here we can say that then QW will be equal to PQ over tangent of 30 degree. That can be written as PQ times cotangent of 30 degree, and we know that cotangent of 30 degree is actually square root of 3, so this will be 50 times square root of 3 because PQ is 50 meter, so in place of PQ I have used 50, and then cotangent of 30 degree is equal to square root of 3, so I have written as 50 times square root of 3. The unit is of course meter because here we are talking about a distance which is QW, so the QW distance is 50 times square root of 3 meter. And next let's take a tangent ratio of the 45 degree angle for the right triangle PQS. There again we can clearly see that the value of QS will be equal to 50 meter. Now instead of doing the tangent ratio, you could even do it with the geometry concept that PQS triangle is a right triangle and one angle there is 45 degree. That means the other angle will also be 45 degree. That means it is an isosceles right triangle, and we know that PQ is 50 meter, then obviously QS will also be 50 meter because those two sides of the triangle will be of equal length. So trigonometrically also we can see that QS is equal to 50 meter, and geometrically also you can prove that QS will be equal to PQ, which is 50 meter. Now let's use the Pythagorean theorem on the right triangle SQW. So there we know the length of QW, and also we have found the length of QS, and we have to calculate the length of WS, which is actually the hypotenuse of that right triangle. So we can say QS squared plus QW squared is equal to WS squared, and then from here we have to calculate the length of WS, and that will be pretty easy. So we can say WS will be equal to square root of QS squared plus QW squared, and then let's plug in the values of QS and QW. So this will be equal to square root of 50 squared plus 50 times square root of 3 whole squared, because QS is 50 and QW is 50 times square root of 3. So I have simply substituted their value, and if we simplify this is going to look like square root of 2500 plus 7500, and that will be equal to square root of 10,000, and that will be equal to 100. And what is the unit here? Well, unit is actually meter. So the distance between W and S, that will be equal to 100 meter, and that is our answer. I hope everything made sense so far. Let's move on to the second question. Here we have the second question. The question says, a man is climbing the slope of a hill which is inclined at theta degree. After climbing the initial 100 meter, he observes that the angle of depression of a point A on the ground is 30 degree. After climbing another 100 meter, he observes that the angle of depression of the same point A is now 45 degree. Find the value of theta. So we have to find out what is that angle, the angle of inclination of the slope of the hill. Now let's try to draw a diagram here. Let's suppose that this blue line is the ground level horizontal line, and then let's assume that this is the slope of the hill. The hill is kind of on the right hand side, and this is kind of the slope of that hill, and a man is climbing this slope, and the angle of inclination of this slope is theta degree, and I have noted it there. So for this question we have to actually calculate the value of theta from the given information, of course. Let's suppose the point on the ground is A, and let's suppose after climbing the initial 100 meter, this is the line of sight for point A. Since the angle of depression has been provided as 30 degree, that means the angle of elevation of the point on the hill from point A will also be equal to 30 degree, because angle of depression and angle of elevation, when we interchange the observer and the object, the angles remain same. So instead of using angle of depression, I am now converting it into angle of elevation, and that is how I have noted here that the angle of elevation of the point on the slope of the hill is equal to 30 degree when observed from point A. But in the question, actually the man observed point A from the hill and the angle of depression was 30 degree. But for simplicity of the diagram, I am using the angle of elevation. And now suppose the second yellow dotted line is the line of sight after climbing another 100 meter. And here the angle of elevation of the second point on the hill will be 45 degree when observed from A. Next, let me assign some alphabetical names here. Now what will be the angle DAC or CAD? Well, that angle is clearly 15 degree, because the big angle is 45 degree and the smaller one is 30 degree. So that little angle will be 45 degree minus 30 degree, which will be equal to 15 degree. Now let's find out what will be the angle BCA or ACB. Well, if you think about it, theta is like an exterior angle for the triangle ABC. So theta will be equal to the sum of the two farthest interior angles. One of them is 30 degree and the other one is something that we are trying to calculate. So we can say that theta is equal to 30 degree plus the angle ACB. And from here we can say that angle ACB will be equal to theta minus 30 degree, and that's what I have noted in the diagram. The easiest way to solve this problem is to use the ratio formula or the MN theorem, and that's exactly what I'm going to do. I'm going to use the ratio formula on the triangle ABD, because we know the ratio of BC to CD. That ratio is actually 1:1, because BC is equal to 100 meter and CD is also equal to 100 meter. So if we use the ratio formula on the triangle ABD, what can we say? Using the ratio formula, we can say that BC plus CD times cotangent of angle ACB will be equal to CD times cotangent of angle DAC minus BC times cotangent of angle CAB. I have already created a separate video on the ratio formula. I have shared the link in the description. Feel free to watch that video. Now I am going to substitute the values of BC and CD and the angles, and let's see how that looks. Well, it's kind of going to look like this. BC is equal to 100 meter. CD is also equal to 100 meter. So I have used 100 plus 100 in place of BC plus CD. And then angle ACB is actually theta minus 30 degree. And then angle DAC is actually 15 degree. And angle CAB is 30 degree. So I have simply substituted the values of BC, CD and the three angles there. And if we simplify this, can it be written like this? 100 plus 100 becomes 200, so I am writing that as 2 times 100 times cotangent of theta minus 30 degree is equal to 100 comes out as a common factor, and then we are left with cotangent of 15 degree minus cotangent of 30 degree. Now the 100 on the left hand side and the 100 on the right hand side, they are going to cancel out each other. So on the left hand side we are going to be left with 2 times cotangent of theta minus 30 degree, and on the right hand side we will have cotangent of 15 degree minus cotangent of 30 degree. Now we are going to write the cotangent of 15 degree and cotangent of 30 degree as the ratio of cosine over sine. So it's going to look like this. It's just the right hand side. I am manipulating the right hand side now, and then I am going to take the LCM of sine of 15 degree and sine of 30 degree and then combine the two fractions together. So in the denominator we will have the LCM, which is sine of 15 degree times sine of 30 degree, and then in the numerator we are going to get sine of 30 degree times cosine of 15 degree minus cosine of 30 degree times sine of 15 degree. And now you can clearly see that the numerator is actually looking like sine A cosine B minus cosine A sine B. That means it is looking like sine of A minus B, and in this case if you consider 30 degree as the angle A and 15 degree as the angle B, so this is clearly looking like sine of 30 degree minus 15 degree, and in the denominator we have sine of 15 degree times sine of 30 degree. Now if you look at the numerator again, it is actually looking like sine of 15 degree, because 30 degree minus 15 degree, that will be 15 degree. So the numerator is actually sine of 15 degree. So the expression can be written like this: sine of 15 degree in the numerator, and on the denominator we have sine of 15 degree times sine of 30 degree. Now this sine of 15 degree between the numerator and the denominator, they are going to cancel out each other, and we are going to be left with 1 over sine of 30 degree. And what is the value of sine of 30 degree? We know that is 1/2. So we can write it like this, and essentially that becomes 2, number 2. So from here you can clearly see that we have a 2 on the right hand side, and also you have a 2 on the left hand side. So let's just rewrite this equation. So we can say that 2 times cotangent of theta minus 30 degree is equal to 2. Now the 2 on the left hand side and the 2 on the right hand side, they will cancel out each other, and then we can say, well, cotangent of theta minus 30 degree is equal to 1, and 1 can be written as cotangent of 45 degree. And then we can clearly see that theta minus 30 degree is equal to 45 degree, and therefore theta will be equal to 45 degree plus 30 degree, that will be 75 degree, and that is our answer. So we have been able to find the value of the angle theta, which turns out to be 75 degree, and this is the angle of inclination of the slope of the hill. I hope everything made sense. Next we are going to solve the third question. Here we have our third question and the final question of this video. The question says, a ship leaves a port at 10 am and heads west at 40 km per hour speed. After 2 hours, the ship changes direction to north 30 degree west. Find its bearing and distance from the port at 1 pm. So the ship left the port at 10 o'clock, went straight west for 2 hours at 40 km per hour speed, and then it changed the direction kind of towards north, kind of northwest, so it is north 30 degree west, and then that way he went for another 1 hour, and now it is 1 o'clock, and we have to find out what is the bearing and the distance of the ship from the port. Now let's draw the diagram. Let's suppose this is the port, point P, that is where the port is, and the ship left this port and went straight to the west. Suppose this is the path it covered in those 2 hours, and let's suppose Q is the point where the ship changed its direction at noon, which is 2 hours after 10 o'clock, right? That will be noon time frame. And after changing the direction, let's suppose that this is the distance that the ship traveled in the next 1 hour. The speed has not changed, it's still 40 km per hour. It just simply changed the direction, and now it headed kind of north 30 degree west. and we have to find this distance, which is PR, that will be the distance of the ship from the port at 1 o'clock, and also we have to find the bearing of the ship with respect to the port. So the bearing would be the angle theta. We have to find out what is that angle. Then the bearing would be north theta west, meaning north so many degree west. And I have made a few small notes on the right hand side. Since the ship changed direction at point Q towards north 30 degree west, if we draw a perpendicular at Q on QP, let's suppose QS is that perpendicular, so the angle SQR will be 30 degree. Now for us to be able to calculate the distance PR, if we can somehow create a right triangle where PR could be the hypotenuse, then we can easily calculate it. And I think if we extend PQ towards the west a little more, and then we drop a perpendicular from R onto the extended PQ, then I think we should be able to form a right triangle right there. So let's try that. Suppose I have extended PQ to the left towards the west, and then I have dropped a perpendicular from R onto the extended PQ, and let's suppose the perpendicular landed at point T. So now if you think about it, RT is a perpendicular, SQ is also another perpendicular, that means they both are parallel, and if we consider RQ as the transversal, then we have two alternate angles right there. So I have denoted that the angle QRT is also equal to 30 degree. Now what is the distance of PQ? Well, that will be 40 km per hour for 2 hours, so that will be 40 times 2, that would be 80 km. And what is the distance between Q and R? Well, that will be 1 hour at 40 km per hour speed, so that will be 40 km. So if you look at the right triangle RTP, in that right triangle we know PQ, but we don't know QT or RT. However, we know QR. So because we know QR and also we know one angle there for the right triangle RTQ, we can easily calculate the length of RT and TQ. So let's quickly calculate the length RT and TQ. To calculate RT, we can use the cosine ratio of 30 degree angle in the right triangle RTQ. We can say cosine of 30 degree will be equal to RT over RQ. And from here, we can then say that RT will be equal to RQ times cosine of 30 degree. Now, what is RQ? Well, that is 40 km. So, this will be 40 times cosine of 30 degree. That would be 40 times square root of 3 over 2. And that will be equal to 20 times square root of 3. So, this is the value of RT. Next, let's quickly calculate the value of TQ. To calculate the value of TQ, let's take a sine ratio of that angle. So the sine ratio of 30 degree in the right triangle RTQ can be written as QT over RQ. And from here, we can say that QT will be equal to RQ times sine of 30 degree. Now, what is RQ? Well, RQ is 40 km. We know that. So this will be 40 times sine of 30 degree, which is 1/2. So that will be 40 times 1/2. And ultimately that will be 20. So the distance between Q and T is actually 20 km, and the distance between R and T, that is actually 20 times square root of 3 km. So now we know RT, and also we have TQ, and we already knew PQ. So essentially for the right triangle RTP, we know RT, we know TP, and we have to find out PR, which is very easy. We are going to use the Pythagorean theorem. Using Pythagorean theorem on the right triangle RTP or PRT, whatever way you want to call it, we can say that RT squared plus PT squared would be equal to PR squared. And from here we have to find the value of PR. So here PR will be equal to square root of RT squared plus PT squared. Now let's plug in the values of RT and PT. So the value will be like this: square root of 20 times square root of 3 whole squared plus 100 squared, and that can be written as square root of 1200 plus 10,000, and that is actually equal to 11,200 under the square root, of course. And if we plug in that value in a calculator, it turns out to be 105.83. So the distance between the 2 points, the port and the current location of the ship, that straight line distance is actually 105.83 km. Now for us to be able to calculate the value of theta, let's first calculate the value of its complementary angle, which is alpha. Tangent of alpha can be written as RT over PT, and let's plug in the values. That is 20 times square root of 3 over 100, and that will be equal to square root of 3 over 5. And from here we can say that alpha will be equal to tangent inverse of square root of 3 over 5. And if you plug in these values in a calculator, the value of alpha turns out to be 19 degree and 6 minutes. So what will be the value of theta then? Well, theta will be 90 degree minus alpha, and that turns out to be 70 degree and 54 minutes. So the bearing of the ship at 1 o'clock is actually north 70 degree 54 minute west. And that is our answer. I hope everything made sense. Thank you for watching. See you in the next video.